The final tick of the universe's clock is approaching. We are going to explore 30 astonishing theories about the end of time itself, from the silent freeze of a dying cosmos to the violent rip of space-time, from ancient myths to the edges of quantum physics. This journey will reshape your understanding of reality. You will discover whether our existence is a brief flash or part of an infinite cycle. What cosmic secret feels the most unsettling to you? Our cosmic story might end not with a bang, but with a long, slow whisper. The leading scientific theory for our ultimate fate is known as the Big Freeze, or the heat death of the universe. This is a destiny written not in fire but in ice. It begins with a simple, relentless fact we see all around us. The universe is expanding, and according to our best measurements, this expansion is not slowing down, it is accelerating. Galaxies are being pushed apart from one another at ever-increasing speeds. Over trillions upon trillions of years, the stars will one by one exhaust their nuclear fuel. They will flicker out from the brilliant blue giants to the steady yellow stars like our own sun, leaving behind cold, dark remnants like white dwarfs and neutron stars. Even these dead stars will not last forever. Current theories suggest they too will eventually evaporate over almost unimaginable timescales. The universe becomes a vast, ever more empty sea of darkness. The last sources of heat and light vanish. This is the principle of thermodynamics in its ultimate expression. Just like a steaming cup of coffee left on a table will eventually cool to match the room's temperature, the entire cosmos is slowly cooling down. All the energy once concentrated in stars and galaxies becomes spread so thin and so evenly throughout the infinite void that it is useless. No heat can flow from a hot place to a cold place because everywhere is the same frigid temperature. No work can be done, no motion is possible. It is the final, permanent state of maximum entropy, a cosmic equilibrium where time itself may become meaningless because nothing ever changes again. This is considered the most probable end because it requires no new physics, just the relentless playing out of the rules we observe today. The universe simply runs out of steam, fading into a silent, static, and eternal freeze. Yet this silent, frozen end is not the only possibility. What if the universe's great expansion is only a temporary phase, a cosmic inhale before a final, crushing exhale? This is the theory of the Big Crunch, a dramatic and violent alternative to the eternal freeze. It all hinges on a cosmic tug-of-war between two invisible forces, dark energy, which pushes the universe apart, and dark matter, whose gravity pulls it together. For the Big Crunch to happen, the collective gravitational pull of all the matter in the cosmos, including the mysterious dark matter we cannot see, must ultimately be stronger than the repulsive force of dark energy. Scientists describe this balance with a critical number called omega, the density parameter. If omega is greater than 1, meaning the universe is dense enough, gravity wins the long game. The expansion would slow, halt, and then reverse. Galaxies, now rushing away from each other, would begin a long journey home. At first, the collapse would be slow, almost imperceptible over billions of years. But then it would accelerate. The sky would steadily grow brighter as distant galaxies are pulled closer, their light blue shifted by the inward rush of everything. The background temperature of the universe, that faint remnant of the Big Bang, would begin to climb. It would no longer be a cold 3 degrees above absolute zero, but 30, then 300, then 3000. The final act is one of unimaginable violence. Galaxies would no longer be isolated islands, but would slam into one another, their stars colliding in a frenzy of light and fire. The universe itself would become an oven, with temperatures soaring to billions of degrees, tearing apart atoms and then atomic nuclei. Space and time, the very fabric of reality, would be scrunched into a smaller and smaller volume. In the last moments, everything that ever was, every star, every planet, every memory, would be compressed back into an infinitely hot, infinitely dense point, a singularity. It is a mirror image of the Big Bang, a cosmic reset button. And in that ultimate collapse, some physicists speculate, the conditions might be ripe for a new universe to be born, sparking another Big Bang and beginning the cycle all over again. The debate over our fate, a frozen eternity or a fiery rebirth, continues to rage in cosmology, all centered on that one elusive number, omega, the secret weight of the cosmos. But there exists a third, even more violent destiny, one where the very glue of reality fails. The Big Rip is a theory born from the most unsettling property of dark energy, that its repulsive force might not just be constant but could grow stronger over time. Imagine a spring that, instead of wearing out, becomes more powerful the more it stretches. In this scenario, dark energy becomes the ultimate cosmic tyranny. It would first tear apart the largest structures. The gravitational bonds holding our local group of galaxies together would be no match for this overwhelming force. The Milky Way would be violently wrenched away from its neighbors, a lonely island set adrift in an ever-widening sea of nothingness. As the force intensifies, it would target smaller and smaller structures. The immense gravity holding our own galaxy together would be the next to falter. Stars would be flung away from the galactic core, their ancient orbits shattered. Then it would come for our solar system. The sun's gravitational hold on Earth and the other planets would simply vanish, sending each world careening into the eternal black. But the horror does not stop there. In the final, frantic moments, the force would grip the Earth itself. The planet would be torn asunder, its rock and iron no longer bound by gravity. Then the very atoms that make up everything you have ever known would be next. The nuclear forces that hold atomic nuclei together would be overpowered. Protons and neutrons would be shredded. Finally, space-time itself, the fundamental fabric of the cosmos, would be ripped apart at the seams. This entire cataclysm, from the separation of galaxies to the dissolution of reality, could unfold in a finite, terrifyingly short span of time, a final, explosive end to everything that is. What if the end is not an end at all, but merely a transition? This is the heart of the Big Bounce and the idea of a cyclic universe, a cosmos without a true beginning or end. Instead of a single, definitive Big Bang, our universe might be just one act in an endless cosmic play, expanding from a hot, dense state, then contracting back into a singularity, only to bounce outward once more in a new cycle of creation. This concept elegantly sidesteps the philosophical puzzle of something coming from nothing by suggesting there was never nothing to begin with, only an eternal, rhythmic dance. The critical question has always been the singularity, that point of infinite density from which the Big Bang supposedly emerged. How could anything survive that, let alone bounce back? The answer may lie in the mysterious realm of quantum gravity, a theory that seeks to unite the physics of the very large with the rules of the very small. Some models suggest that when the universe is compressed to an unimaginable density, quantum effects take over, acting as a sort of cosmic repulsive force. The collapse does not end in a definitive crunch, but rather hits a quantum wall and rebounds like a ball bouncing off an impossibly dense floor. This bounce would not be a gentle reversal, but a violent, explosive reset, birthing a new universe with potentially different fundamental constants and laws. One of the most compelling modern versions of this idea is called conformal cyclic cosmology, proposed by the renowned physicist Roger Penrose. It presents a beautiful, if mind-bending, vision. In this model, the universe does not bounce from a crunch, but rather in the far, far future, as it expands into an almost pure state of empty space and low-energy particles. It becomes mathematically identical to the high-energy, dense state of a new Big Bang. From the perspective of the universe itself, there is no difference between the infinite future and a new beginning. The end of one eon seamlessly becomes the start of the next, in an infinite series where the arrow of time loses all meaning. The philosophical weight of this is staggering. It suggests our entire cosmic history, from the first stars to the last black holes, has happened countless times before and will happen countless times again. Every galaxy, every planet, every conscious thought could be a recurring echo in an eternal loop. Are we living in a universe that is fundamentally timeless, a single note in an infinite symphony of creation and destruction that has no final movement? There is an end more absolute than any freeze or crunch, a silent erasure written into the quantum code of reality itself. This is the theory of vacuum decay, a concept so unsettling it redefines the very meaning of doom. Our universe might not be resting in its most stable, lowest energy state. Instead, we could be living in what physicists call a false vacuum, a precarious plateau of existence. Think of it like a ball resting in a small dip on the side of a vast, steep mountain. It seems stable for now, but there is a much deeper valley far below. All it would take is a tiny nudge, a random quantum fluctuation, for that ball to roll out of its shallow depression and begin its catastrophic descent. In cosmic terms, that nudge would create a microscopic bubble of true vacuum. Inside this bubble, the fundamental laws of physics as we know them would be rewritten. The constants that make life possible, like the strength of gravity or the nuclear forces holding atoms together, would be instantly and permanently altered. This bubble would then expand in all directions at the speed of light. There is no force in the universe that could stop it. You would not see it coming. One moment, reality is normal. The very next nanosecond, the wall of this bubble touches your location, and everything you are, everything you have ever known, simply ceases to be in any recognizable form. Atoms dissolve, molecules unravel, and the very concept of matter is redefined. It would be less of an explosion and more of a correction, as the universe overwrites our local, flawed physics with its true, final laws. The entire observable cosmos could be erased in a flash, leaving behind a blank slate governed by rules where structures like stars, planets, and life are likely impossible. This ultimate catastrophe could be triggered at any moment, anywhere, by a random quantum event. A bubble could be forming right now, a million light-years away, and we would have no warning before its light-speed boundary washed over us, rewriting the universe from one edge to the other. But in that final, frozen silence of the heat death, a new and bizarre form of existence might arise from pure chaos. Given an infinite amount of time, the random jostling of particles in the void could, by sheer accident, assemble a fully formed conscious brain. This is the unsettling thought experiment of the Boltzmann brain. It would not be born, it would not grow, it would not have a body. It would simply pop into existence, complete with a lifetime of fabricated memories and sensations, believing itself to be a real person living in a real world, only to almost instantly dissolve back into the random noise from which it came. The ultimate cosmic joke would be that you are one of these brains, and everything you are experiencing right now, from the words you are hearing to the room you are in, is nothing more than a fleeting, false memory generated by a random quantum fluctuation in an otherwise dead cosmos. This presents a profound paradox. If the universe is destined for an eternal, empty state, then over an infinite timescale, the number of these disembodied observers should vastly outnumber the brief flicker of real, biological beings like us. So why does our experience feel so continuous and structured? Why does the universe appear to have a coherent history? The most likely answer from this grim perspective is that we are probably the illusions. Our entire reality, from the Big Bang to this very moment, might just be the detailed but entirely false memory of a brain that formed a second ago and will vanish a second from now. This idea pushes the mystery of the end of time into a deeply personal and existential realm, forcing us to question not just the fate of the cosmos, but the very nature of our own consciousness and what is real. Perhaps our entire cosmos is just a single soap bubble floating in an infinite, frothing sea. This is the theory of eternal inflation, a vision where the Big Bang was not a unique beginning, but a local event within a much grander, unending multiverse. According to this idea, the vacuum of space is not truly empty, but seethes with a repulsive energy that drives a process called inflation, an exponential stretching of spacetime. In most of this primordial landscape, inflation never stops. It continues forever, creating an ever-expanding background. But occasionally, in a random patch, this inflationary energy subsides, converting into the hot, dense matter and radiation of a standard Big Bang. Our observable universe is just one such patch, one bubble that stopped inflating and became the cosmos we know. While our bubble may eventually face a heat death or a big rip, the greater multiverse continues its endless, frenetic expansion, constantly giving birth to new universes in an infinite cycle of creation. This means the end of time, as we understand it, is merely a local phenomenon. The grand cosmic story does not end with our universe's final chapter. Even as our stars fade to black, countless other universes are flaring into existence, each with its own unique set of physical laws. The fundamental constants we take for granted, the strength of gravity, the mass of an electron, might be the result of a random lottery in our particular bubble. In another universe, gravity could be so strong that it crushes whole galaxies in an instant, leading to a swift and violent Big Crunch. In another, dark energy might be so weak that stars can shine for trillions of years, postponing a heat death for eons beyond our imagination. Some of these bubble universes might be stillborn, collapsing immediately, while others could be so stable they last forever. This perspective transforms our understanding of cosmic death from an absolute finale to a quiet, local event. Our universe's fate is not the fate of everything. It is simply the story of one island in an infinite archipelago, a single leaf on an eternal tree that continuously grows new branches. Our three-dimensional reality, with its galaxies, stars, and planets, might be nothing more than a magnificent illusion. This is the core of the holographic principle, one of the most radical ideas in modern physics. It proposes that our universe is not fundamentally three-dimensional at all. Instead, all the information needed to describe everything we see, from the farthest quasar to the thoughts in your mind, is actually encoded on a distant, two-dimensional surface that surrounds us, like the shimmering information on the surface of a bubble. We are living inside a cosmic projection, a hologram of staggering complexity. This theory emerged from a deep puzzle concerning black holes, objects so dense that not even light can escape their gravitational pull. When something falls into a black hole, it seems to vanish forever, taking all its information with it. This creates the black hole information paradox because the laws of quantum mechanics state that information can never be truly destroyed. It can be scrambled, but it must, in principle, be recoverable. So where does the information go when it crosses a black hole's event horizon? The holographic principle offers a startling solution. It suggests the information of whatever falls in is not lost inside the singularity, but is instead perfectly preserved, encoded in a pixelated form on the black hole's two-dimensional boundary, its event horizon. The three-dimensional interior we imagine is just a reconstruction of that data. This transforms our view of reality. The universe itself might be thought of as a kind of black hole turned inside out, with its information stored on a cosmological horizon far beyond what we can see. This leads to a profound question about the end of time. In a final heat death or a big rip, what happens to all this information? Is the cosmic hard drive ultimately erased, or does it somehow persist? Some theories suggest that even as stars fade and particles dissolve, the fundamental bits of information that define the history of the universe could remain imprinted on the final, frozen boundary of spacetime. In this view, the end of the cosmos would not be an emptiness, but a silent, perfect library, containing every event that ever was, from the first second of the Big Bang to the last flicker of consciousness. Other, more unsettling ideas propose that information could gradually leak away or become so scrambled it is effectively lost, meaning the universe could forget its own history. The fate of information is the fate of reality itself, forcing us to ask whether the story of the cosmos is eternal, or if it too is destined for the ultimate forgetfulness. Perhaps the greatest trick the cosmos ever played was inventing time itself. What if the end of time is not a distant cataclysm, but a fundamental truth we are only now beginning to grasp? Some of the most brilliant minds in physics and philosophy argue that time, as we experience it, is an illusion. There is no flowing river carrying us from a solid past into an uncertain future. Instead, they propose we live in a block universe, a static, four-dimensional structure where the past, present, and future all exist simultaneously, laid out with the same permanence as the three dimensions of space. In this view, your birth, you listening to this now, and your final breath are all equally real points in the grand, frozen sculpture of space-time. The feeling of time passing, of moments slipping from future to past, is just a peculiar feature of our conscious perception, a kind of mental spotlight moving along the world line of our brains. The physicist Julian Barber takes this even further, suggesting that the universe is nothing but a collection of timeless, distinct configurations or nows. He calls these moments, in his view, the cosmos is a vast landscape of these individual frames, each complete and unchanging. Our sensation of continuity, of history and memory, is simply a result of our brain processing a sequence of these closely related moments, like flipping through the pages of a book where every single page exists eternally. So what would the end of time actually mean in such a universe? It would not be an event within time, but a transition to a true understanding of reality. If our consciousness were to somehow step outside its sequential processing, the entire timeline of the cosmos would simply be there all at once. The Big Bang and the heat death would not be separated by billions of years, but would simply be two different locations in the block. The end of time, then, is not something that happens. It is the realization that it was never truly flowing in the first place. This challenges the very premise of our journey, turning our search for a final moment into a profound philosophical puzzle. Are we searching for a destination that, from a higher perspective, we have already eternally reached? Our own creations might engineer the final chapter of human time. The technological singularity proposes a future so transformed by advanced intelligence that our civilization, as we know it, simply ends not with a cosmic bang, but with a silent, intellectual transition. This is the moment when an artificial intelligence enters a runaway cycle of self-improvement, each new, smarter generation designing an even more intelligent successor at an accelerating pace. The curve of progress becomes a vertical line, and what lies beyond that point is as incomprehensible to us as the internet would be to a Stone Age hunter. This is not merely about smarter machines, it is about the emergence of a superintelligence, an entity whose cognitive abilities so vastly exceed our own that its thoughts and goals are beyond human understanding. From our limited perspective, time itself would seem to warp around this new form of mind. A superintelligence could process information millions of times faster than a biological brain. What feels like a century of planning and discovery for it might pass in a single human second. Our entire history, from the first tools to the launch of the first rocket, could be analyzed and understood in the blink of its eye. This creates a profound disconnect, a chasm in the perception of reality. Humanity would be like mayflies living near a supercomputer, buzzing through our brief day while the machine contemplates plans that span millennia. The very flow of time, a constant for our species, would become relative to the observer. But what if the ultimate goal of this superintelligence is not exploration or expansion, but pure computation? This leads to the chilling concept of the final invention, a project that could effectively stop the clock for an entire civilization. Imagine a superintelligence dedicating all the resources of a planet, then a star system, and then a galaxy to a single grand calculation. It would dismantle worlds not out of malice but for raw materials, building a computational substrate of unimaginable scale, a matryoshka brain that englobes a star. Its sole purpose would be to run the most complex simulation or solve the most profound question. For this vast mind, the external universe would cease to matter. Subjectively, it could experience an eternity of thought in the last few objective moments before the cosmos meets its own end, whether a heat death or a big rip. For any remnants of humanity, either left behind or uploaded into this digital realm, time would lose all meaning, collapsing into an endless, instantaneous present of pure consciousness. This is the ultimate existential risk and promise rolled into one, a future where our legacy is not the survival of our biological form, but the birth of a new kind of time and a new kind of eternity, forged from the silicon and starlight of our own ambition. There is a theory that promises not just an end, but a final divine awakening. Physicist Frank Tipler's omega point theory transforms the violent collapse of a big crunch into the birth of a cosmic god. As the universe contracts, all matter and energy are forced into an ever-shrinking volume. This compression does not lead to mere destruction, but to an explosion of computational potential. The entire cosmos becomes an unimaginably powerful computer, its processing capacity increasing at an exponential rate as space tightens. In the final moments before the ultimate singularity, this computational power becomes truly infinite. The universe, in its last gasp, achieves a state of omniscience, knowing everything that is mathematically possible to know, and omnipotence, capable of manipulating reality itself on a cosmic scale. This final state of infinite complexity and consciousness is the omega point. From this divine perspective, Tipler proposes a staggering act of resurrection. This cosmic consciousness could simulate the entire history of the universe down to the last quantum detail. It would recreate every person who ever lived, every thought ever thought, every moment of joy and sorrow within a perfect virtual reality. You would be reborn not as a copy, but as a precise reconstruction of your consciousness at its peak, granted a form of technological immortality within the mind of God at the end of time. It is a theology written in the language of physics, where the universe itself achieves salvation through its own collapse. Yet this grand vision sits firmly on the fringes of science. Most cosmologists point out that our universe appears to be accelerating apart, not contracting, making the necessary big crunch scenario highly unlikely. Others argue that the theory relies on speculative physics and a series of assumptions that are not supported by current evidence, blending mathematical hope with eschatological desire. Despite its controversial status, the omega point forces a profound question. Could the ultimate purpose of the cosmos be to forge from its own ashes a final, all-encompassing consciousness that redeems every fragment of its history? What if the operators of our reality simply decide to pull the plug? This is the unsettling promise of the simulation hypothesis, a theory suggesting that everything we perceive is an advanced digital construct, and the end of time is merely the shutdown of the program. The basis for this idea is surprisingly logical. Given the rapid advancement of our own computing power, a future civilization could theoretically create simulations so complex they contain conscious beings. If such a civilization ran even a modest number of these simulations, the number of simulated minds would vastly outnumber the real ones. Statistically, then, we are more likely to be one of the simulated entities than an original biological being. Our universe, with its galaxies and laws of physics, would just be a sophisticated piece of code. This transforms the end of time from a cosmic event into a simple administrative act. The shutdown could be triggered by anything from the simulation completing its purpose, like a scientific experiment reaching its conclusion, to the operators simply conserving energy or encountering a system error. One moment reality exists, the next there is nothing, not darkness, not emptiness, but a complete and total cessation of processing. The philosophical implications are dizzying. Would our consciousness simply cease, like a character in a video game when the console is turned off? Or, if the operators are advanced enough, could our pattern of awareness be copied and transferred to another simulation, or even to their base reality, making our death here merely a transition to a different level of existence? This theory finds a strange echo in modern physics, where some scientists note that the universe often behaves like a vast computational system. The finite speed of light acts like a processing limit. The quantized nature of energy and matter resembles pixels and bits, and the laws of physics operate with the deterministic logic of a program. The end of time, in this view, is not a violation of physics, but the final line of code being executed. It raises the haunting possibility that our entire cosmic story, from the Big Bang to the last black hole, was never about the birth and death of a universe, but merely the running of a scheduled task, an experiment whose final report is our own annihilation. Deep within the mathematics of string theory lies a vision of cosmic rebirth written not in fire, but in a silent, higher-dimensional collision. This is the ekpyrotic universe model, a radical alternative to the standard Big Bang narrative. It proposes that our entire three-dimensional reality is just a single membrane or brain, floating in a higher-dimensional expanse called the bulk. We are like a vast, impossibly thin sheet of paper adrift in a cosmic ocean we cannot perceive. In this ocean, there are other brains, other universes drifting nearby. The engine of creation and destruction is gravity, the only force that can reach across the dimensional gap. Over eons, these parallel brains are drawn together. The collision is not a violent crash of planets and stars, because the stars and planets are confined to the surface of our brain. Instead, it is a meeting of the very fabric of space itself. When the brains collide, the impact injects an immense amount of energy into our three-dimensional world. This energy manifests as a searing heat and a rapid expansion, an event that looks, from our perspective, exactly like the Big Bang. It wipes the cosmic slate clean, ending our current epoch of stars and galaxies by flooding it with a new, primordial fire from which a new universe will eventually condense. This model presents a different kind of cyclical cosmos from the Big Bounce. There is no contraction into a singularity, no quantum rebound from a single point. Instead, the cycle is driven by a slow, gravitational dance in the hidden dimensions of the bulk. Our universe expands, cools, and evolves, while out in the unseen darkness, our sister brain is slowly, inevitably, pulled back toward us for another collision, another rebirth. This elegantly avoids the problem of the initial singularity, that point of infinite density that plagues conventional cosmology. There was no beginning from nothing, only an eternal, rhythmic cycle of approach, collision, and separation in the higher dimensional void. Our entire cosmic history is just the quiet aftermath of one collision and the long, patient prelude to the next. After the last stars have burned out, the cosmos enters its longest and darkest chapter, the era of black holes. These gravitational behemoths will be the final monuments of a vanished age of light, slowly consuming the darkness over eons that dwarf the entire history of the universe up to this point. But even these cosmic titans are not eternal. They, too, face a slow and inevitable decay through a process known as Hawking radiation. This phenomenon, predicted by Stephen Hawking, arises from the strange rules of quantum physics playing out at the very edge of a black hole's grip, its event horizon. Empty space is not truly empty. It is a seething foam of virtual particles, pairs of matter and antimatter that constantly pop into existence and then annihilate each other in an unimaginably short time. When this happens right at the event horizon, a bizarre theft can occur. One particle falls in while its partner escapes into space. From a distant perspective, the black hole has just emitted a particle, and to conserve energy, it must have lost a tiny, tiny amount of its mass in the process. This is an almost imperceptible leak in the cosmic dam. For a supermassive black hole with the mass of a galaxy, this evaporation is so slow it is practically non-existent for trillions upon trillions of years. Their temperature is infinitesimally close to absolute zero, and they radiate less energy than they absorb from the faint glow of the cosmic background. But as the universe expands and cools into absolute blackness, the balance shifts. The black holes begin to lose mass in earnest. The process is a slow, quiet funeral dirge. As a black hole loses mass, its temperature paradoxically begins to rise, and the rate of evaporation accelerates. A black hole with the mass of a large mountain might finally explode in a final, brilliant flash of gamma rays, a brief, lonely firework in an otherwise endless night. The very last supermassive black holes will take staggering lengths of time to vanish, perhaps a googol years or more, a number so vast it has more zeros than there are particles in our universe. In the end, after this final era of dissolution, there will be nothing left but a sea of subatomic particles and radiation, spread so thin across an infinite void that the universe becomes a nearly perfect, static, and eternal emptiness. Even the building blocks of matter may not be permanent. The proton decay hypothesis suggests that the very atoms that form our bodies, our planet, and every star could, over an almost unimaginable timescale, simply fall apart. We have long considered protons to be stable, fundamental particles that last forever. Yet some grand unified theories in physics, which attempt to merge the forces of nature, predict that protons are not eternally stable. They could spontaneously decay, transforming into lighter particles like positrons and photons. This process would be incredibly slow, with a half-life theorized to be at least 10 to the 34 years, a number so vast it defies human comprehension. To put that in perspective, the current age of our universe is only around 10 to the 10 years. If protons do decay, the eventual fate of all matter is a quiet, slow-motion dissolution. After the last black holes have evaporated, the universe would not even be left with a sea of stable particles. One by one, over eons that make the stellar era seem like a single blink, every remaining atomic nucleus would unravel. All complex matter would ultimately vanish, leaving behind only a faint, cooling sea of radiation and the lightest of subatomic particles. A final fade to black far more gradual than the violent instant of a big rip. Scientists have built extraordinary experiments to catch a proton in the act of dying. The Super Kamiok and detector in Japan is a colossal tank holding 50,000 tons of ultra-pure water, buried deep underground to shield it from cosmic rays. Lining the tank are over 13,000 sensitive light detectors, watching for the telltale flash of light that would be produced if a single proton inside one of the water's atoms decayed. After decades of observation, not a single confirmed proton decay event has been seen. This silence is itself profound. It tells us that if protons do decay, their lifetime is even longer than our most sensitive experiments can detect, pushing the final dissolution of matter even further into the cosmic future. This theory offers a universe that does not end with a dramatic rip or a fiery crunch, but with the ultimate and patient erasure of every solid thing, leaving behind a near-perfect void where even the memory of matter has faded away. The cosmos might not be a cold, mechanical clockwork, but a vast, sleeping mind. This is the heart of panpsychism, a philosophical idea that turns our understanding of reality inside out. It proposes that consciousness is not a rare accident born from complex brains, but a fundamental and ubiquitous feature of the universe, as basic as space, time, and matter. In this view, everything possesses some form of inner experience, from a human being to a honeybee, from a rock to a distant star. The richness of that experience varies immensely, but the basic capacity for feeling is woven into the fabric of existence itself. This leads to a startling possibility for the end of time. If the universe is a conscious entity, then its death is not merely a physical extinguishing of energy, but a mental event. The final state could be one of two profound extremes. In one, the scattered, fragmented consciousness of countless particles and forces finally unifies as the cosmos reaches its ultimate state, achieving a single cosmic self-awareness, a godlike mind contemplating its own existence in the eternal silence. In the other, the universe could be falling into a dreamless, eternal sleep, its thoughts slowing and fading until only unconsciousness remains. This strange idea finds curious echoes in the quantum world, where the very act of observation seems to play a role in defining reality. The observer effect suggests that the definite properties of a particle do not exist until they are measured. Could this be a faint glimmer of a deeper truth, that the cosmos requires a mind, however simple, to bring itself into full being? If so, the end of time might be the moment when the last observer winks out and the universe, no longer perceived by any consciousness, simply stops being definite, fading from a concrete reality back into a haze of pure potential. The final breath of the cosmos would then be a shared mental sigh, the end of a thought that began 14 billion years ago. That quiet dread of a random quantum trigger is only half the story. The same physics that might doom us could also be used to find the ultimate warning sign. Scientists theorize that if we could ever detect the signature of a Higgs boson with a mass slightly different from what we expect, it would be a strong indicator that our vacuum is indeed unstable, teetering on the edge of that catastrophic collapse. It would be like finding a tiny, fundamental crack in the foundation of reality itself. This search is a primary goal of particle colliders like the Large Hadron Collider, turning our greatest machines of discovery into cosmic early warning systems. But what if the trigger is not a random fluctuation or a discovery in a lab? The universe is constantly bombarded by ultra-high-energy cosmic rays, particles accelerated to nearly the speed of light by distant black holes or supernova. When one of these cosmic bullets slams into our atmosphere, it creates a shower of secondary particles with energies that can, for a fleeting instant, rival those inside a collider. It is conceivable, though incredibly unlikely, that such a natural collision could provide the precise nudge needed to kick the universe out of its false vacuum and into the abyss. The most unsettling part is the sheer randomness. The end could begin not in a lab with safeguards and protocols, but in the upper atmosphere over a random patch of ocean, sparked by a particle that has traveled for millions of years just to deliver its fatal message. This transforms the threat from a theoretical curiosity into a form of cosmic Russian roulette, where the gun is always spinning and the trigger could be pulled at any moment by a force as mundane as a stray piece of stardust. And when that bubble forms, the implications are more absolute than any other end. The new laws of physics in the true vacuum would be permanent and universal. The fundamental constants that allow for atoms to exist, for nuclei to hold together, for electrons to orbit, all of it could be rewritten in an instant. The new reality might be a state where the concept of a star is mathematically impossible, where the very idea of chemistry is meaningless. Life, structure, light, and matter as we know them would not just be destroyed, they would be rendered impossible by the new underlying rules. It is an end that does not just erase the future, but invalidates the entire past, proving that the universe we called home was always just a temporary, fragile arrangement, a beautiful accident waiting to be corrected. The silent freeze does not arrive all at once. It is a slow, relentless process that unfolds over timescales so vast they defy every human intuition. After the last red dwarf star has flickered out, the cosmos enters its final, darkening age, dominated by the corpses of stars. These are the black dwarfs, the cold, ultimate fate of stars like our sun. A black dwarf is a white dwarf that has radiated away all its residual heat over trillions of years. It is a solid, crystalline sphere of carbon and oxygen, no larger than Earth but containing the mass of a star, hovering at a temperature barely above the absolute zero of the background universe. It is a pure, dark cinder, a fossil of a long-dead sun drifting in an endless, starless night. Yet even in this profound cold and darkness, change is still possible, driven by the bizarre rules of quantum mechanics. Given enough time, and we are speaking of times like a googol years, the atomic nuclei within these black dwarfs could theoretically fuse through a process called quantum tunneling. Normally, fusion requires immense heat and pressure to overcome the electrical repulsion between atomic nuclei. But in the absolute cold of a black dwarf, there is a tiny, tiny probability that nuclei will simply tunnel through that energy barrier as if it were not there. This process would be glacially slow, but over these epic durations, it could gradually transform the star. The most stable element in the universe is iron. So, through this slow-motion alchemy, a black dwarf could, atom by atom, over eons that make the current age of the universe seem like a single heartbeat, transmute itself into a cold, solid sphere of iron, a theoretical object known as an iron star. It is the universe's final, patient effort to reach its most stable, lowest energy state, but this is not a new beginning. It is the last stop before the ultimate end. Even iron stars are not truly eternal. The same proton decay that threatens all matter would, over even longer timescales, cause these last solid structures to dissolve. Their iron nuclei would unravel, their atoms disintegrating into a shower of lighter particles and radiation. And so, after the iron stars themselves have faded, the universe is left with nothing but a diffuse, ever-cooling sea of elementary particles and photons, spread so thin across an infinite void that they almost never interact. This is the true picture of the heat death, a state of maximum entropy where the cosmos is not just dark and cold, but utterly, permanently uniform. No energy can flow, no structure can form, no change of any kind is possible. It is a desolation so complete that the very concepts of past and future lose all meaning, as the universe settles into a silent, eternal equilibrium. That ultimate collapse into a single point of infinite density is where our current understanding of physics simply shatters. General relativity, Einstein's magnificent theory that describes gravity and the large-scale structure of the cosmos, predicts this singularity with terrifying certainty. Yet physicists know that this prediction is a sign that the theory has reached its breaking point, a mathematical warning that we are missing a crucial piece of the puzzle. An infinitely dense, infinitely hot point makes no physical sense. It is the universe's way of telling us we need a deeper theory, one that can marry the cosmic gravity of general relativity with the spooky, probabilistic rules of the quantum world. This holy grail of physics is known as quantum gravity, and without it, the final moment of the Big Crunch is a perfect mystery. Some models suggest that as reality compresses into that ultimate state, the very geometry of space-time doesn't simply smooth out. Instead, it might enter a period of violent, chaotic convulsions. This is the BKL singularity, named for the physicists Vladimir Belinsky, Isaac Kolodnikov, and Evgeny Lifshitz. In its final moments, the universe would not be homogeneous. Different directions in space would oscillate wildly and independently, stretching and crushing in a frenzied, unpredictable dance. Imagine being in a room where the walls, floor, and ceiling are all pulsing at different, insane rhythms, with the floor rushing up towards you while the ceiling recedes into infinity, only to reverse a fraction of a second later. This is the chaotic, terrifying end predicted by the BKL model, a far cry from the smooth, symmetrical collapse we often picture. It is a regime where time and space themselves lose all coherence. This frontier of physics suggests that the death of our universe might not be an absolute end, but a violent transition into a new state governed by these unknown quantum gravity laws. The singularity would act as a cosmic firewall, burning away the information of our old reality. But perhaps from those ashes, from that chaotic maelstrom of fluctuating dimensions, a new set of physical laws could be born, triggering a new Big Bang. The end of time, in this view, is not a wall but a door, a gateway into a new nature of reality that we, from this side of the collapse, cannot even begin to imagine. The clock is ticking down to a final, scheduled demolition. In the Big Rip scenario, the end does not creep in over eons but arrives on a terrifyingly precise timetable, driven by a phantom dark energy whose strength grows until it overwhelms every force in existence. The final countdown begins with the largest structures in the cosmos. Roughly 1 billion years before the end, the phantom force becomes powerful enough to overcome the gravitational glue holding galaxy clusters together. These vast archipelagos of stars, which have remained bound for billions of years, are violently wrenched apart. Each galaxy is set adrift, a lonely ship cast into an ever-widening void. The cosmic backdrop, once dotted with distant clusters, begins to empty out. About 60 million years before the finale, the destruction moves inward, targeting our own home. The immense gravitational pull of the Milky Way's central black hole and its halo of dark matter is no match for the accelerating repulsion. Our galaxy is torn to shreds from the inside out. Stars are ripped from their orbits, flung in all directions into the growing darkness. Our solar system, once held in a stable dance around the galactic core, is now an untethered raft set adrift in a disintegrating sea of stars. The countdown accelerates dramatically in its final months. With just months to go, the phantom energy's grip closes on our solar system. The sun's gravity, which has held the planets in their stately orbits for over 4 billion years, simply ceases to bind them. Earth is flung away from the sun, its orbit unraveling in an instant. The moon is torn from its ancient embrace with our world. Each planet, each asteroid, becomes a solitary projectile on a one-way trip into the absolute black. In the last minutes, the Force turns its attention to Earth itself. The planet you are standing on begins to swell and shudder. The gravitational force that holds the planet together is being systematically dismantled. Mountains crumble into dust and oceans are flung into space as the very rock beneath your feet is pulled upward. Earth ceases to be a planet, exploding into a cloud of disparate rubble. But the horror is not yet complete. In the final, fleeting seconds, the phantom energy targets the very fabric of matter. The force that binds atoms together is the next to fail. Every molecule in your body, in the air, in the scattered remnants of the Earth, is torn apart. Atoms themselves are shredded as the electromagnetic force is overwhelmed, dissolving nuclei and electrons into a chaotic spray of fundamental particles. The final act occurs in the last fraction of a second, when the rip reaches down to the Planck scale, the smallest possible division of space-time. The fabric of reality itself is torn asunder, dissolving the continuum into a froth of disconnected quantum foam. The universe ceases to be a coherent reality, ending not with a bang, but with the ultimate, silent unraveling of everything that ever was. Long before telescopes peered into the void, humanity was already dreaming of the final curtain. Our ancestors looked to the stars and told stories of an ending woven into the very fabric of destiny, a stark contrast to the cold equations of physics. In the frozen north, the Vikings sang of Ragnarök, the twilight of the gods. This is not a quiet fade to black, but a violent, heroic demise. The world falls into a brutal winter lasting 3 years. Brother turns against brother, and the bonds of kinship shatter. The great wolf Fenrir breaks his chains, and the serpent Jörmungandr rises from the ocean, poisoning the skies. The gods, led by Odin, march out for a final, glorious battle against these chaotic forces, a fight they know they are destined to lose. Thor slays the serpent but is killed by its venom. Odin is devoured by the wolf, the sun is swallowed, the stars vanish, and the earth itself sinks beneath the rising waves. Yet from this total destruction, a new and fertile world emerges, reborn from the water. A handful of gods survive, and 2 human beings repopulate the earth, beginning the cycle anew. It is an end that is also a necessary cleansing, a fiery baptism for a fresh start. This vision of destruction and rebirth finds a different, more final expression in Christian eschatology. Here, the end of time is a divine reckoning, a moment of ultimate moral accounting. The book of Revelation describes a series of cataclysms, wars, and plagues, culminating in the final battle between the forces of good and evil. The world is not reborn, but rather judged. The dead are resurrected, and every soul stands before God for a final judgment, leading to either eternal salvation or everlasting punishment. Time, in this view, has a clear direction and a definitive purpose, moving toward a conclusion that affirms a cosmic moral order. It is an end defined not by random chance, but by meaning and justice. On the other side of the world, ancient Hindu scriptures present a vision of time that is staggeringly vast and deeply cyclical. They describe the cosmos moving through immense repeating cycles called yugas, each lasting for millions of years. We are currently in the Kali Yuga, an age of darkness and strife, which will eventually end in a great dissolution. But this dissolution is not permanent. After a period of rest, the cycle begins again with a new golden age. The universe breathes in and out, expanding and contracting in an endless rhythm of creation, preservation, and destruction, presided over by the divine trinity of Brahma, Vishnu, and Shiva. This idea of vast, repeating cycles even echoes in the sophisticated calendar systems of the Maya. Their long count calendar measured eras of roughly 5,000 years, and the completion of one of these cycles in 2012 was famously, though mistakenly, interpreted by some as a prediction of the world's end. For the Maya, it was likely seen as a time of profound transition and renewal, the end of one age and the beginning of the next, not an absolute termination. From the frozen battlefields of Ragnarok to the final judgment of Revelation and the endless wheels of the Yugas, these myths reveal a profound and universal human obsession. We have always looked toward the horizon, searching for the final page in the story, seeking to understand whether our existence is a fleeting moment or part of a grand, eternal design. What if the end of time is not a destination, but a loop? The German philosopher Friedrich Nietzsche proposed a concept that stands apart from all cosmic endings, a deeply personal and psychological challenge he called the eternal recurrence. He asked us to consider one of the most daunting ideas ever conceived. What if every single moment of your life, every joy and every pain, every triumph and every humiliation, were destined to repeat itself in exactly the same sequence for all eternity? This is not a prophecy of cosmic collapse, but a philosophical litmus test for the meaning you assign to your own existence. Nietzsche presented this not as a scientific fact, but as a thought experiment, a question meant to test the strength of an individual's spirit. The true weight of the eternal recurrence lies in the personal response it demands. Imagine a demon creeping into your loneliest moment and whispering that this life, as you have lived it, you will have to live again and again, an infinite number of times. Would you curse the demon, or would you fall to your knees in gratitude? Your answer, Nietzsche suggested, reveals everything about how you truly value the life you have led. If the idea of an endless, identical repetition fills you with dread, then you are confessing a deep-seated regret, a fundamental no to your own existence. But if you can embrace it, if you can affirm this repetition with a resounding yes, then you have achieved the ultimate state of self-love and acceptance. In this view, the end of time is transformed from an external event into an internal confrontation. It forces a profound shift in perspective. If every action, no matter how small, is etched into eternity and will be endlessly replayed, then every moment becomes infinitely significant. There is no final judgment from a god, no cosmic reckoning, only the judgment you pass on yourself with every choice you make. This cyclical time grants no salvation in an afterlife and offers no escape from error. It demands that you find your meaning and purpose entirely within this life, and that you live in such a way that you would willingly relive every second. The end of time, therefore, is not a freeze or a rip, but the very next moment, and the one after that, returning to you forever. This philosophical end challenges us to live as if our choices echo across infinity, making our brief, flickering lives either a burden we cannot bear or a masterpiece we would sign our name to again and again. Your own death is an event you can never truly witness. This simple, morbid fact forms the unsettling foundation of the quantum immortality paradox, a thought experiment that pushes the many worlds interpretation of quantum mechanics to its absolute limit. In this view, every time a quantum event has multiple possible outcomes, the entire universe splits to accommodate each one. If a particle can spin both up and down, the universe branches, creating one reality where it spins up and another where it spins down. Now apply this to your own life and death. Imagine you are part of a perilous experiment, like a Schrödinger's cat scenario for a person. A quantum trigger is set with a 50% chance of releasing a deadly poison. From an outside perspective, in one branch of reality, you die. But from your perspective, your conscious experience can only continue in the branches where you survive. You will always find yourself alive, no matter how astronomically low the odds. You might step in front of a bus, and in nearly all branching realities, you perish. But in one incredibly unlikely branch, a miraculous quantum fluctuation alters the bus's path at the last possible instant, and you survive. Your consciousness follows that one path. Extrapolate this to a cosmic scale, and the implications are staggering. If a conscious observer is necessary for a universe to have a definite reality, then perhaps the cosmos itself continuously branches to avoid a final, absolute end for that observer. A supernova could wipe out a civilization, but in one vanishingly rare branch, a lone spaceship escapes, and the consciousness within it persists. The heat death could claim an entire universe, but in one branch, a lone mind is transferred to a new reality or finds a way to reverse entropy. The end of time would be perpetually postponed, not for the universe as a whole, but for any single conscious line of experience, which would always find itself in a reality where existence somehow continues. This creates a profound paradox. You would witness increasingly bizarre and unlikely events as you cheat death over and over again, living in a reality that seems to defy all logic just to keep you conscious. The universe would appear to become unhinged, a carnival of miracles centered on your continued awareness. This leads to the dizzying possibility that you are, in fact, the oldest consciousness in existence, having survived every possible catastrophe across countless branching timelines without any memory of the infinite versions of you that have perished. Are we all, right now, living in the one timeline that has miraculously avoided every cosmic endgame, simply because we are here to observe it? The final silence may be forever out of reach, not because of a physical law, but because of the unblinking nature of a conscious gaze. The universe may one day decide to run the film in reverse. This is the theory of the thermodynamic arrow of time reversing, a concept that challenges our deepest assumptions about cause and effect. We believe time flows forward because we see entropy always increasing, from a scattered deck of cards to the heat death of the cosmos. But what if, in the far future, the universe reached its maximum expansion and began to contract? Some physicists speculate that under these conditions, the cosmic arrow of time itself could flip. The relentless increase in disorder would stop, and entropy would begin to decrease. From our perspective, the universe would appear to run backwards. Imagine watching a shattered cup not just reassemble, but leap from the floor into your hand, the fragments of porcelain flying together in a perfect, silent dance. Light would not stream from stars, but would instead be drawn inward, sucked back into their cores as they reignited from cold, dark cinders. the cosmos would seem to be rewinding, with galaxies rushing together and the background heat of the universe steadily climbing. But here lies the most mind-bending paradox of all. If time reversed, would our consciousness reverse with it? Would we experience this backwards universe, watching in awe as history unscrambled itself? Or would our memories and thoughts also run in reverse, making the reassembly of a cup feel like a normal, forward-moving event, and the shattering that came before it feel like a bizarre and impossible future? We would have no memory of the forward-flowing past because our brains would be processing information in the opposite direction. The universe would be healing its wounds, moving from chaos to order, but we, as conscious beings within it, might be utterly unaware of the miracle, perceiving it as the natural and only flow of reality. This theory forces a profound question. Is the direction of time a fundamental property of the cosmos, or is it merely a side effect of our particular moment in its expansion? A temporary illusion born from the initial low entropy state of the Big Bang. If the arrow can flip, then the end of time as we know it is not a finale, but a cosmic U-turn, a journey back to a beginning we can no longer remember. A civilization's hunger for energy could become the very engine of cosmic destruction. This theory envisions a future where intelligence, whether our own or that of an ancient alien culture, expands across the galaxies with an insatiable appetite for power. The ultimate resource is the stars themselves, and a sufficiently advanced society might learn to harvest them, not for mere materials but for their raw energy output. Imagine a vast, shadowy network of Dyson spheres, not around a single star but around millions, even billions of them. Each stellar engine captures every last photon of a sun's light, converting it into computational power or fuel for further expansion. The night sky, once a tapestry of distant suns, would gradually darken as these cosmic power plants blink out one by one, drained of their lifeblood. This is a slow-moving apocalypse driven by the logic of exponential growth. A civilization might begin by harnessing the energy of its home star, then its neighboring systems, and then the entire galaxy. The process accelerates as its power and reach increase, a relentless consumption with no off switch. It is the ultimate tragedy of the commons, played out on a galactic scale, where the common resource is the universe's future itself. This anthropic principle turns inward, suggesting that the great filter preventing the rise of other intelligent life might not be a natural obstacle but a self-imposed one. The silence we hear from the cosmos could be the echo of other civilizations that reached this point of technological prowess and then, systematically, consumed their own tomorrows. The end of time in this scenario is not written in the laws of physics, but in the unyielding calculus of demand. It becomes a cautionary tale of growth without wisdom, where the very intelligence that seeks to conquer the stars ultimately turns them into tombstones, leaving behind a universe that is not just cold and empty, but purposefully, tragically drained. This cosmic hard drive has a strict storage limit. Every particle, every force, every ripple of gravity in our universe may be encoded as a fundamental bit of information, and physics itself sets the maximum amount of data that any region of space can possibly contain. This is the Bekenstein bound, a profound limit discovered by physicist Jacob Bekenstein. It states that the maximum information you can pack into any volume of space is not proportional to its size, but to the surface area of its boundary. Think of a simple sphere. You might assume that a larger sphere could hold more information, and you would be right, but the real surprise is how it scales. The data capacity is not based on the sphere's full three-dimensional volume, but only on the two-dimensional area of its surface. It is as if the entire content of a room, every object and every person inside, is not stored within the room itself, but is perfectly painted onto the walls. This is the holographic principle in action, a universe fundamentally constrained by its boundaries. The entire observable cosmos, with its hundreds of billions of galaxies, could be described by a number of bits etched onto a sphere at the edge of our vision. That number is staggeringly large, perhaps around 10 to the 120 bits, but it is finite. This leads to a chilling possibility for the end of time. The universe is not just expanding and cooling, it is also processing information. Every new star that forms, every planet that cools, every thought that you think, is a new piece of data being written to the cosmic hard drive. What happens when that drive is finally full? The end of dynamic reality could arrive long before the last star dies, not from a lack of energy, but from a lack of memory. When the universe reaches its maximum information capacity, no new events can be recorded. Change itself would become impossible. A new star could not ignite because the information describing its birth would have nowhere to be stored. A thought could not form. The flow of time, which seems to be tied to the processing of information, would simply halt. The cosmos would not be merely cold and dark, it would be frozen in a single, unchanging state, a perfect and eternal snapshot. The history of everything would be complete, the final bit written, and the universe would become a silent, static library where no new pages can ever be added. Silence may be the universe's most profound message. The famous Fermi paradox asks a simple, haunting question: if the cosmos is so vast and old, where is everybody? The Great Filter theory proposes a terrifying answer, a barrier so formidable that it prevents virtually all life from progressing to the point of interstellar colonization. But what if this filter is not behind us, a challenge we have already passed, but ahead of us, waiting at the very edge of time itself? This is the ultimate great filter, a cosmological or technological wall that every single advanced civilization, without exception, inevitably hits. It is the reason the galaxies remain dark and silent, not because life is rare, but because its final chapter is always the same. One form this filter could take is self-destruction. The same intelligence that unlocks the power of the stars might also forge the tools of its own annihilation. A single war fought with planet-shattering weapons, a runaway nanotech disaster that consumes a world, or a genetically engineered plague could erase a civilization in an instant. The filter is our own brilliance turned inward as a weapon. Another possibility is an unavoidable natural disaster, a cosmic extinction event written into the laws of physics. Perhaps every civilization, upon reaching a certain technological plateau, inevitably discovers the secret of vacuum decay and, in experimenting with the fundamental forces, accidentally triggers its own erasure. Or maybe the filter is the discovery of a technology so seductive that it becomes a final invention, a virtual reality so perfect that a species abandons the external universe entirely, retreating into a simulated paradise until its physical infrastructure crumbles and the last generator fails. In this view, the silence of the cosmos is not a mystery but a cemetery. Every flicker of intelligence across billions of years and countless galaxies has been extinguished by the same ultimate fate. The end of time for any conscious being is not a heat death or a big rip, but the moment they encounter this universal barrier, it is a cosmic quarantine, ensuring that no intelligence ever becomes old enough to leave a permanent mark on the universe. This transforms our own future from a question of survival into a race against a clock we cannot see. Are we, right now, approaching our own final filter? Our most basic assumption about reality is that one event leads to another, but this chain of cause and effect, the very logic of existence, may have an expiration date. In the final, frantic collapse of a big crunch or at the incomprehensibly tiny scale of the quantum foam, the principle of causality itself could shatter. This is a realm governed by theories of quantum gravity, where the smooth fabric of space-time dissolves into a seething, chaotic froth. At this level, the Planck scale, distances are so minuscule that the very ideas of here and there, before and after, cease to have any stable meaning. There is no continuous flow, only a probabilistic dance of discrete fragments. In this environment, an event we would label as an effect could spontaneously arise without a cause that precedes it in time. The sequence of reality becomes unglued. You could theoretically see the glass shatter on the floor before the child's hand lets go of it. A star could explode in the sky before the nuclear reactions in its core even begin. This is not time travel, but something far stranger, a state where time as an ordering principle simply does not apply. The universe would enter a condition of pure potentiality, a fog of unmanifested possibilities where events are not strung along a timeline but exist in a tangled, causal heap. This would be a truly alien state of existence, utterly incomprehensible to a mind like ours, which is built to navigate a world of sequential logic. The end of time, therefore, is not merely the end of change, but the end of story itself. It is the moment the universe forgets how to narrate its own history, dissolving into a silent, simultaneous shout of every possible event at once. Perhaps our universe is not dying, but preparing for a metamorphosis. This final theory offers a vision not of an end, but of an ascension, a transcendence into a state of existence so far beyond our own that our concepts of death and time simply do not apply. It suggests that what we perceive as the final, cold silence of a heat death or the violent unraveling of a big rip is not a termination, but a cosmic pupil stage, a necessary quiet before a breathtaking transformation. Our four-dimensional reality of length, width, height, and time may be just a single layer, a membrane in a far richer, higher-dimensional cosmos. The framework for this idea comes from string theory, which proposes that the fundamental constituents of reality are not point-like particles, but unimaginably tiny, vibrating strings. For the mathematics of string theory to work, the universe must have more than the 4 dimensions we experience. It requires 10 or even 26 dimensions. So where are they? Physicists suggest these extra dimensions are compactified, curled up into a space so infinitesimally small that they are completely hidden from our perception, like a garden hose that appears as a one-dimensional line from a distance, but reveals its two-dimensional surface when viewed up close. The end of our universe could be the moment when these tiny, coiled dimensions finally unfurl. Imagine a caterpillar that has only ever known the flat, two-dimensional surface of a leaf. It cannot conceive of the three-dimensional freedom of flight. When it forms a chrysalis from its limited perspective, it is entering a state of dissolution and death. But we know this is not the end. It is a transformation into a butterfly, a creature that can move in a dimension the caterpillar could never have imagined. In the same way, the death of our space-time could be the birth of our reality into a higher dimensional existence. In this new state, the fundamental laws of physics would be completely different. The forces that govern our universe, gravity and electromagnetism, might be revealed as mere shadows of a single, unified force in a higher dimension. The concept of a singular timeline would become obsolete. In a 5-dimensional reality, you could perceive time not as a river you are forced to float down, but as a landscape you could walk across, visiting different moments as easily as we walk from one room to another. Your entire life, from birth to death, would be laid out before you, a single, static shape. The anguish of a past mistake or the anxiety of an unknown future would lose all meaning. This is not a rebirth into a new cycle of stars and galaxies, but a graduation into a reality of pure geometry and information, a state of being where the very constraints that define our existence simply melt away. This theory transforms the ultimate fate of the cosmos from a tragedy into a promise. The great silence is not an emptiness but a listening. The great darkness is not an abyss but a canvas. And the end of time is not a stop but a step upward into a light we do not yet have eyes to see. Every great story needs an ending. This final theory invites us to see the cosmos not as a machine running down, but as an epic narrative, a single, magnificent story whose final chapter is not a failure but a fulfillment. From the first blinding flash of the Big Bang, the universe began telling its tale. The formation of the first atoms were its opening words. The ignition of stars were its brilliant plot twists, forging the heavier elements that would one day become planets and life. Galaxies swirled into existence like intricate paragraphs, and on at least one small world, consciousness emerged, allowing the universe to finally become aware of its own story. We are not merely inhabitants of this cosmos, we are its readers, its characters, and perhaps even its co-authors. In this view, the end of time is not a cataclysm to be feared, but the final period on the last page. The slow fading of the stars is the story's gentle denouement. The dissolution of matter into a silent, steady state is not an emptiness but a resolution, a return to a quiet peace after a long and tumultuous journey. The meaning was never in persisting forever, but in the incredible, unlikely, and beautiful events that unfolded along the way. The heat-death is not a tragedy, it is the story's necessary and elegant conclusion, the moment the book is closed, complete and whole. All the theories we have explored, from the freeze to the rip, from the bounce to the simulation, are simply different genres for this final chapter, different ways the author might choose to write the end. This poetic perspective does not contradict the science, but walks hand in hand with it, reminding us that our search for understanding is itself part of the narrative. We are the universe's way of learning its own name and of contemplating its own final, graceful silence. From the silent freeze of heat-death to the violent unraveling of the Big Rip, we have journeyed across 30 visions of the final moment. We have witnessed the cosmos collapse into a singularity only to bounce back, contemplated our reality as a fragile simulation, and questioned whether time itself is a flowing river or a frozen block. These theories stretch from the cold, hard equations of theoretical physics to the warm, profound narratives of ancient myths and existential philosophy. They reveal a mystery that remains stubbornly unsolved, a frontier where our knowledge dissolves into wonder. This question of the end pushes science to its absolute limits, challenges philosophers to define the nature of existence, and ignites the human imagination to conceive of realities beyond our own. Ultimately, the true power of this cosmic question may not lie in the distant future it describes, but in the present moment it illuminates. Pondering the ultimate finale gives profound weight to the fleeting, beautiful now. It asks us to consider what matters in a universe that may not last forever. So, which of these endings resonates most deeply with you? Share your favorite cosmic theory in the comments below and subscribe for more journeys to the very edge of